Assalamu alaikum, dear student. Today's our topic is transformers, and the very first question says that a step down transformer is 100% efficient. It has an input voltage of 240 volts AC. Input, as it says that input, so we are going to write here that this is VP, and an output voltage of 60 volts like VS. The current in the primary coil is given to you, which is 0.5 ampere. It means that you can write it like this. IP current, which is in the primary coil, and what is the current in the secondary coil, and we have to figure out IS. Very easy. Like you have to use the equation VSIS equals to VPIP. When you will put all these values here, like 240 times 0.5, and here Vs is 60 volts times Is, you are able to get the answer. So when you are going to solve this, you will get the answer, which is 2 amperes. So the next question is a step-up transformer produces a 60 volts AC output, like it's the output here. It means that this is Vs. From a 12 volt AC input, it means that this is Vp. The number of turns in the secondary coil, like Ns, is given to you this, and how many turns are there in the primary coil, like you need the number of turns in the primary, which is Np. And we know the relationship between voltage and the number of turns, that is Np over Ns is equals to Vp over Vs. So from here, easily you can get the answer. You can substitute the values here. Vp is 12 volts, 60 volts is the value of Vs. Np we need to figure out. Just shift this Ns on the other side and multiply with this. Like you will multiply this with 50. So here your answer will be, when you are solving this, you will get the answer 10. Okay. All right. Third part, power losses in transmission cables are reduced by increasing the transmission voltage. What is the explanation of this reduction? There are 4 options which are given here. The very worst option is that the current decreases, reducing thermal energy loss. Yes, actually, you know that here is the power equation, P is equals to VI. When we are going to increase the voltage, then the current decreases to keep the power's value constant. So by decreasing the current, we are actually reducing the value of thermal energy losses, which is the correct answer of it. The rest of the options are not correct. For example, the current increases, increasing the flow of charge. Like, no, it's not like that. The resistance of the cable increases, reducing the current. Not possible again, because while increasing the resistance, you know that what happened, that the thermal energy will also be lost if we are increasing the resistance. So the resistance of the cable decreases. This is also not good at all. It's not matching with the information which is provided to us. Like if we are providing the power to the system, power generated by the power generated in the power station will be there, and if we are increasing the voltage by using the step up transformer, we are actually reducing the value of current, which is in turn gives us the less thermal energy loss, and this is the factor which is needed here. Okay, the next question is a transformer has NP turns and the primary coil and NS turns in the secondary coil. Which row gives the values of NP and NS for a transformer that steps up a voltage of 1200 volts to 36,000, right? They need that NP is given to you, NS is also there. So which row gives you the correct value of NP and NS as the step up voltage of this to this? Step up as, so it means that here, let's suppose this is Here it's NP, and here, and this is VP, sorry, and this one is VS. This one is VS. So as we know, the relationship is that NP over NS is equals to VP over VS. So when we are going to add the values here, which is 1200 over 36,000. So what we are getting here, that is the answer will be like, you will cut these zeros here and you will get the answer 31 over 30, right? This is the answer. So this is NP over NS. Now you can take these factors from here, just divide them up and you will get the ratio 1:30, and that will be the best answer. So for example, if I'm taking A option initially, so if you are taking it NP over NS, like 2000 divided by 60,000, so what you are getting, 2000 divided by 60,000. So when you are dividing them up, you are getting 1:30. So here A option is correct. But if you are taking a look on the other options, like for example, C and D, these are not as a part of it because here they are representing that the transformer is stepped down because the number of turns in secondary will be less. So from these two options, if we are going to divide them up, we will get the answer 1/30, which is equivalent to this one. As we know that the ratio of VP over VS should be equal to the ratio of NP over NS. In this way, we are able to get the answer for it. So A option in it is correct. The next part. The diagram shows a transformer. Which materials are the most suitable for the core and for the coils? So for the core and for the coils, the options are, like you can say, only two of the materials are provided to us, that is copper and iron. And it's in different formations, like, you know, which one is suitable for us. So copper, no, not both of them are not made up of copper. We need iron core should be there for it as a core because it is very important to transfer the magnetic field lines from primary towards the secondary coil. So for the core, the material should be iron. So here we have two options for it, but for the coil, primary coil and secondary coil, it should be made up of copper because it has low resistance, so maximum current can flow through it. So the option C will be the best option. Moving on to the next part, next question. The diagram shows a transformer with an alternating voltage of 100 volts applied to the primary coil. What is the voltage produced across the secondary coil? Again, very easy question, like number of turns are provided to you here. This is VP. This one is NP. Here, this is NS, and they want that you can calculate VS. Okay, so you can easily calculate by writing like this, that VS over VP is equals to NS over NP. So just rearrange the equation and you will get the answer. You can substitute this over there and by putting the values, very simple, all of the values I have mentioned here. So when you will substitute the values in this equation, you are able to get the correct answer. And the answer for it is it's C option 200. Like you can check even by putting the values. NS is 80, NP is 40 times 100, right? So you can see here, this is 4 2s 8 and 2 times 100 will give you 200 answer. So here, this is the answer for it. Next question is, a transformer has an output of 24 volts like VS when supplying a current of 2 ampere. The current in the primary coil, this is IP, and the transformer is 100% efficient. Calculate the power output If the power output is there, you have to take the output voltage and output current to get the answer. P is equals to VI. When you will multiply 24 times 2, so you will get 48 watt answer. The voltage applied across the primary coil. So if they need that, we will calculate this. So what should be the formula for it? Voltage applied across the primary coil. Here you will use the data and you can see initially in the question that all the data is provided to you. So you are going to solve this question by using that data. Okay, so here you are going to use this equation. VSIS is equals to VPIP. This is the formula. And we need to calculate the primary voltage in the primary coil. So by substituting the values here, it will be 48 as we have calculated here that output voltage, output power will be this one by using these values here. It's 48 and IP is 0.4 times VP. So just divide these two factors, like VP will be equals to 48 divided by 0.4. You will get the required answer. Okay, and the answer is 120 volts. Moving on to the next part of it, what is meant by the statement that the transformer is 100% efficient? So it means that there will be no energy loss or no power loss. So that's why the transformer is 100% efficient. It means that you can even write like this, that power input is equals to power out. Or there is no energy loss or no power loss. You can even write like that. The next part of it is how the transformer changes an input voltage into the output voltage. Here, you know that what is the actual method of transformer is that you have to mention that there will be a current supplied, alternating current, which is provided to the primary coil. For example, here I'm going to draw the diagram for you people. This is the core of it. Here we have primary coil. Here, this is the secondary coil. When you are providing the alternating voltage here in the primary coil, then because of changing in the value of current, there is a changing magnetic field, and these changing magnetic field lines are cut by the secondary coil. This one is the secondary coil, and here this one is the primary coil. Primary coil. So the secondary coil will cut the magnetic field lines of the primary, so the EMF is induced in it. So this is the way how the input voltage provides you the different output voltage. So you have to mention here that there will be a changing in magnetic field. This field will pass through the core, or it will be cut by the secondary coil, which induces an EMF in the secondary coil. And there will be the number of turns on the secondary which determines the output voltage. Totally depends upon the number of turns in the secondary coil. More number of turns in secondary coil means that there will be more EMF will be induced, and if there are less number of turns as compared to the primary, so there will be the less EMF which is induced in the secondary coil. So here, this is the answer of it, right? The next part is an engine on a model railway needs 6 volt AC supply. A mains supply of 240 volt AC is available. Mains is this one, like this one is VP and this one is VS. In the space below, draw a label diagram of a transformer suitable for producing the required supply voltage. Label diagram, required supply voltage is important here. So you are supposed to draw the transformer, which is step down transformer. It means that here we have less number of turns. Here we have more number of turns. The required voltage you have to mention here. This is the main supply here, which is 240 volts. providing you, and here you are getting 6 volts. This is the iron core, and this one is secondary coil. And here this is primary coil. Dear students, here it is mentioned that the diagram should be labeled properly. So it's important to label the diagram. Sometimes in the marking scheme, this iron is underlined. It means that for them, iron is very, very important. Don't skip this word. And as one more thing is mentioned here, that you should mention the required supply voltage. So required supply voltage is this one, which is already given here. So mention this also on the diagram when you are drawing it up. Suggest suitable number of turns for the coils. Yeah, this is very important question again. Like here, what you need to do is you have to use this equation, that is Vp over Vs is equals to Np over Ns, right? Vp is 240 and Vs is 6 volts. And here this will be Np over Ns. Like when you are going to cut this up, you will get 40 ratio 1, which is actually Np ratio Ns. Means that number of turns in primary should be 40 and number of turns in secondary should be 1. It's not necessary that you will write 40 ratio 1. You can write any other number as well, which should be in the ratio of 40 and 1. Like for example, I can also add this number 80 ratio 2, because when you are going to solve this up, you will get again 40 ratio 1 and so on. You can increase them up, but make sure that it will be in the ratio of 40 and 1. Moving on toward the next part of it. The power needed for this model engine is 12 watt. This is the power. Calculate the current taken from the mains when just this engine is in use, assuming that the transformer is 100% efficient. So here, as you know that this power is already given to you, which is the power output because it's needed. They need that we will calculate the current from the mains, which is IP. As you know that the formula is VPIP is equals to VSIS, right? VSIS is already given to us, which is 12 watts. And VP is the main supply because they're talking about the mains, and in mains they provided 240 volts. So 240 times IP. So you are going to divide this 240 on the other side and you will get IP. IP will be equals to 12 divided by 240. And the answer is 0.05 amperes. The next part is explain why transformers will only work when connected to an AC supply. Actually, for the working of the transformer, we need the change in magnetic field lines. And that can only be possible from AC source. Because if there is a change in current, then we have the change in magnetic field. So when we have the change in magnetic field line, this causes the EMF to be induced in the secondary coil. So this is the way how it works. So very important thing is that you know that change in magnetic field lines is needed as magnetic field and current are directly proportional to each other. So if there is a change here in the current, it will also create a change in the magnetic field line here, which in turn will causes the EMF to be induced. Okay. And in transformer, EMF is induced in the secondary coil. So please mention that as well in the question. This figure shows the basic parts of a transformer. Use ideas of electromagnetic induction to explain how the input voltage is transformed into an output voltage. Use the 3 questions below to help you with your answer. What happens in the primary coil? Very easy. In the primary coil, you are providing the input source. The current will start flowing through it, right? And you know, every current carrying conductor has a magnetic field around it. This magnetic field, as I told you, that current and magnetic fields are directly related to each other. So as we are providing the AC source here, so change in current will causes the change in magnetic field lines, right? So this is what is happening in the primary coil, right? So what you have to write that there will be an AC input which causes the constantly changing current through the coil. That changing current causes the magnetic field which is constantly changing again, okay? This is what it is needed here in the primary coil. So 2 marks are there for this part. So we have completed these 2 points. This is 1 mark question here. What happens in the core? So in the core, that is just a channel to transfer the magnetic field from primary towards the secondary coil, right? So it's just transferring the magnetic field lines from primary to secondary. That's why iron is best for it. What happens in the secondary coil now? Like in the secondary coil here, what's going on? These magnetic field lines, these are going to cut secondary coil and EMF is induced here. This is what happening in the secondary coil, right? So what you have to write, changing magnetic field cut secondary coil, which induces EMF in the secondary coil. State what is needed to make the output voltage higher than an input voltage. How you are getting the higher voltage in an output? By increasing the number of turns in the secondary coil. So more turns on secondary is needed as compared to the primary. The next part is that the core of this transformer splits along X and Y. Explain why the transformer would not work if 2 halves of the core were separated by about 30 centimeter. So here this is X, and Y. They are saying that these should be split up just like that. For example, it is cut from this portion and these are separated 30 centimeter apart, right? So the distance between them is 30 centimeter. This is a question. So they are saying then what happens? You know that if they are further apart from each other, so these magnetic field lines should not cut the secondary coil because there is a huge distance between them. So you can say that there will be no transfer of magnetic field lines from primary to the secondary coil, right? Then the last part of this worksheet and this question is that a 100% efficient transformer is used to step up the voltage of a supply from 100 volts to 200. Like this is VP here and this is VS here. The current in the primary coil is 0.4 ampere. Calculate the current in the secondary coil. So IS is needed. So very easy again, VSIS is equals to VPIP. Put the values in this equation, you will get the answer. Like VS is 200 times IS is needed. VP is 100 volts and IP is 0.4 amperes. So when you will solve this question, it will be 40 on 200. We'll get IS from here. Just solve by using the calculator. You can solve it very easily. The answer will be 0.2 ampere. So I hope that the transformer topic will be clear to you. Thank you so much for watching this video. I hope this will clear your concepts of transformer. Thank you so much.